All right. Wait on this page here. Okay. So we're going to learn a new way to solve certain problems here. So notice this picture is I have a triangle and I have two interior angles. And I have one exterior angle. And those are the ones I'm labeling there. So as we look at problems A and B right below, notice that those are the same type of problem. We have two interior angles and we have one exterior angle. So we don't have all three angles inside the triangle. We have two interior and this one exterior. And same thing for the bottom ones. And then if you flip to the first page real quick, those last two problems that we put a star by, those are also the same type of problem where we have two interior angles and one exterior angle. So we've already seen one way to solve these. We're going to see a different one right now. So in this situation right here, angles 1 and 2 are the two interior angles. And it's true that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3, that exterior angle. So as we look at problem A, which are the two interior angles? Jackson?
30 and 4x plus 12 plus 2.
Yeah, 30 and 4x plus 2. So these are the two interiors. We're going to do 30 plus 4x plus 2. And then what's the exterior angle?
Equals
8 plus 6x. Yes. So that's just based off this rule right there. We're just applying that rule and setting up this equation. So it's a new situation we're going to recognize.
Does that work every time?
It works every time.
Every time?
Every time. Every time. Let's solve this one real quick, and then I'll show you why it works.
What are we supposed to fill in on the top?
Yeah, I'll do that in a sec as well. Okay, so I combine like terms on the left side. How do I get the x's together? What do I do again? Just a quick algebra review, in case we forgot. Jackson?
Subtract 4x.
Subtract 4x from the 6x. What does that equal? 2x. And then what else would I do? Yeah, do I add it or subtract it? Okay. Yeah, it's 12. Divide both sides by 2. X equals 12. Okay. So yeah, this does work every time. So just look at this example for a sec here. Let's say that I've got angles of 70 and 50. And I've got X and Y right here. So this is telling us that if we do 70 plus 50, it's going to equal which letter? X or Y? It's going to equal Y, right? That's the rule we just learned. If I do 70 plus 50, that's 120. We're being told that this should be Y. Let's see if this is true. So how would we find X in this situation? What could we do? Okay, 180 minus 70 minus 50. What does that equal? 60 degrees. Okay, if 60 is here, would we have 120 on the other side? Yeah, we would. Because then what would we do? to find y? Well, we could have 1570. That's what we just learned, but what were we doing before? We would subtract from 180. Yeah. So notice this is kind of what I pointed out before, is that when we do that the first way, before we learn this new rule, is we would add 50 and 70, which is 120, and we would do 180 minus 120 to get 60, which is this one. And then, again, we would do 180 minus 60, which we already know is 120, because that's sort of what we started with. Okay. So, using that same rule for letter B, turn to your partner. What equation could you set up for problem B? Oh, wow. Beautiful, you guys. Okay, so again, in geometry, remember the most important part is what equation do you set up? Can you look at a picture and recognize what equation would be true? That's the important skill that we're working on. Okay, so now we'll fill in the top part here. This theorem says the sum of the two remote interior angles is equal to the exterior angle of the triangle. When we say remote interior, these are the interior angles that are not connected to the outside angle. So we see how angle 3 is over here on the outside. There is an interior angle that's right next to angle 3. That would be this one. The two remote interior angles are the other two. Jack's a question.
Oh, it's going to be the matters if it's connected.
Yeah. Yes, it does. If it's connected, if we had like, 50 here and 70 here, we wouldn't want to add 50 and 70. We would just want to subtract 70 from 180 to find that exterior angle. Yeah. Okay. Back on the first page, the warm-up. Okay, so we already solved E and F, so we know the answer, but set up two new equations, one for each of these, based on the new rule that we just learned. Let's work together on this.
Oh, they can solve it or just not.
Just set it up. That's it, like the answer is.
Yeah.
Okay, so for letter E, what would be our new equation that we could solve based on our new rule here? Great job. Equals 120. Nice. Okay. If we solve the blue equation, will we still get x equals 3?
Yeah.
Yes, we will. It's the same thing. We're actually one step away. If I subtracted 60 from both sides in the very first one, it would be the same exact equation. So again, it doesn't really matter which way you do it. Sometimes it can be faster to do it the same way. What would be our other equation for letter F, Jackson?
12x plus 80.
Close. Equals 180?
Or I'm at 1. Or 1.
So what you're doing is you're doing 3x plus 4 plus 8x plus 4 equals 140, right? So that'd be 11x plus 8.
Oh, shit.
Okay.
Oh, I'm at close. My bad.
Yeah. Language moves. Okay. All right. You guys do on the back page letters A and B. All right. So equation for letter A, what do we got? Homer. Nice. All right, and so we solve that. What do we get for x? Yeah, 6. Okay, is that the end of the problem? No, what do we need to do? Lost it. Yes, okay, so it's asking for the measure of angle FAB, so that's FAB right there. So we need to substitute that in. And what do we get when we substitute in x? 75. All right. So we'll say 75 degrees since it's an angle. Make sure you put the degree sign here. Usually MathSpace has a degree sign there for you, but this paper doesn't. Okay, equation for letter B. Rachel. Nice. And so we combine like terms. What would I do next to solve this? Algebra, yeah. What would my next step be? Yeah, combine like terms already on the same side. What would be my next step here? Yeah, subtract 6x from both sides. 9x plus 5 equals 86. Then, what's next? Jackson. What's next? What do I do next?
Subtract 5 is 80.
Yeah, subtract 5 from both sides. 81 equals 9x. And then last step, divide by 9. Okay, and then we're looking for YDC, so we plug that in. What do we get when we plug that in? What is it, 140? All right. Degrees.
140.
Okay. All right, so let's go to the inside pages now. The first one. Okay. So we're learning something here called the triangle inequality theorem, which says the sum of the length of any two sides of a triangle is greater than the length of the third side. So our process is going to be add the two smallest sides. And they need to be greater than the length of the longest side. So it needs to be greater. I don't know. Okay, so number one, what are the two smallest sides? 3 and 4. So I do 3 plus 4. What does that equal? 7. Is 7 longer than the longest side? Yes, it is. The longest side is 5. So if it is longer, if it's greater, we say yes. Let's go. That's good. And number 2, what are the two smallest sides? 16 and 7. So we do 16 plus 7. What does that equal? 23. Okay, is that longer than the longest side? No, it's not. 23. It's the same as the longest side. Can we make a triangle? Okay, for number 3 here, what are the two smallest sides? 5 and 5, right? Also 5 is the longest side. 5 plus 5 is 10. Is that longer than the longest side? Yeah, it is, so we can make a triangle here. What type of triangle would this be? Equilateral. Okay, that's not too bad, right? You guys do 4, 5, and I guess that one's number 3. So I do 8.5 plus 6.5. That equals 15. 15 is greater than 13.5. Would I say yes or no for this? Yes. That's what we're looking for. Okay, so I do 28 plus 12. That's 40. 40 is less than 41. What would we say, yes or no? Yeah, I would say no. We need it to be greater. Okay, and 5 plus 10 is 15. What would we say for this? Okay. Feeling good about that? Not too bad, right? So, next page here. We got some triangles here with a missing side. So here's the thing. Could I choose 1 as my answer for this side here? No, because 10 plus 1 is 11. That's less than 14. That's not going to work. Okay, could I use 10,000? No, that's way too big. Okay. So to figure out the limits here, I need to do 14 minus 10, which is 4, and 14 plus 10, which is 24. And so my side needs to be between 4 and 24. And so notice it's 4 is less than, the missing side is less than 24. I'm just writing it a little bigger. So 4, would 4 work? No. Because 4 plus 10 equals 14. But would 4.01 work? Yeah. 4.001. Yeah. And we could go on forever like that. So, very easy to find these numbers. You just subtract them. Would I do 8 minus 15 or 15 minus 8? Yeah, we want to do 15 minus 8. We want to do positive numbers here. 15 minus 8 is 7. 15 plus 8 is 23. Yep. And that's our answer. Here's how we would say it. We would say the missing side must be between 7 and 23. So that's how we would say our answer out loud. Or we could say the missing side is greater than 7 and less than 23. Sometimes you look at that and you're not sure how to say it out loud. Okay, do the last two problems there, letters A and A.
Why is it A and A?
I forget.
A is here, B is there.
Yeah, depending on just the number of notes pages. Okay. So the first one, how do we find the first number? 19 minus 4 is 15. How do we find the second number? 19 plus 4. We could say the missing side is between 15 and 23. What do you guys get for the second one? The missing side? What is it? 18 and 5. Those are the ones that we have. We want to do 18 minus 5. Mm-hmm. 18 plus 5. 23. So we would say the missing side is between 13 and 23. Or greater than 13, less than 23. Okay. Couple things. We have math space homework. And we have a quiz next class. So there you go. Those are the things.